All right, this is Mr. Jern, and I am going to help you with some conservation of momentum problems. Remember, the idea of conservation of momentum is that the total momentum of all the objects stays the same from the beginning to the end. So we typically break it up into a before and an after, the initial and the final. So we have here a question about perfectly inelastic collisions. What that means is when in a perfectly inelastic collision, a simple way to think of that is that when two objects collide together, they stick together and then they continue moving together, or maybe they stop. All right, that's always an option. That's always a possibility, I should say, is that they might just stop moving if the momentums cancel out. So we have a 65 kilogram ice skater traveling south at 6 meters per second. They run into an 85 kilogram skater traveling in the opposite direction at 4.5 meters per second. Opposite is underlined. Come back to that in a second. That's just a little hint to help you out. At what speed and in what direction do the skaters travel if they move together after the collision? All right, so what happens is this is exactly what I was talking about. Two objects, they're moving in opposite directions, they smash into each other, and they start moving together. Now, remember, or keep this in mind, they don't have to be moving in opposite directions. You can have one object moving kind of slow and then another one coming up from behind, and they crash into each other, and then they're moving in the same direction. So watch out for that. The only really difference that makes is if they're going in opposite directions, like in this example here, that just means one of the numbers is going to have to be negative. So if they're moving in the same direction, then you can just don't worry about negatives. You could just keep every number positive, okay? Because in physics, we use negative and positives to indicate different directions, opposite directions, because negative is the opposite of positive. Okay. So let's set this up. The idea is that the momentum initially, the initial momentum, is equal to the final momentum. In other words, the total momentum of the skaters before they collide will be equal to the total momentum after they collide. So I could even squeeze the word in total to remind us it's not just one of the skaters, it's both of the skaters. All right. And so what that means is the total momentum. So the mass of the first skater, I'm just going to call mass the A skater. So we'll call the 65 kilogram skater A. All right, it makes it a little easier. And skater A's velocity, mass times velocity, because momentum is mass times velocity, plus the mass and velocity of skater B. So we've got, that's supposed to be a B. So we've got the mass and velocity of these two skaters, and which means we have the momentum of both these skaters. And combined, that is going to be their initial velocities. Okay, not combined. That's their initial velocities. Combine their total momentum will add together, and it's going to be equal to the total momentum after they collide. All right. So here's what I like to do for these because they collide. Watch what I do here. I'm going to say, all right, I'm going to use parentheses. The mass of skater A, they collide and stick together. So plus the mass of skater B times the final velocity of both together because they are moving together. So I combine their mass together. Okay, just think of them as one big blob of a skater now moving together. And you get this. And so we don't have to worry about the final velocities because they're the same velocity. They're moving together. So that's kind of the nice thing about an inelastic collision. This is actually kind of the opposite of an explosion. If you remember that question from earlier, if you've checked that out, because you start with the total mass together. In this case, we're ending with the total mass together. So I'm actually going to rearrange the equation here before I solve for any, before I start plugging in any numbers, because what are we trying to solve for? We want to know what direction and what speed, so the velocity. So right away, I'm going to just say, all right, let's get velocity final by itself. So I'm going to divide by m m of the A plus m of the B skater. That will cancel that out over here on the right-hand side of the equation. I'm going to divide that over here because whatever you do to one side, you have to do to the other side. Now, you might be like, if you're just kind of rushing through this, you might be like, hey, those masses cancel out, right? No, they don't. That's not how this works. You can't divide before you add. And so they do not cancel out. It's just going to be a little bit nicer. So I'm also going to kind of flip this equation around so that I like to, have what I'm solving for on the left. I think it's just kind of, how we were all taught. So what happens is we get mass of the first skater times their velocity initial plus the mass and initial velocity of the other skater divided by their total mass. All right, so that's the setup. And it might look a little daunting, but honestly, once we plug in the numbers, you'll be like, oh, is that it? Is just that? Okay, cool. So I'm going to plug in the numbers now. I'm going to substitute and solve it. So mass and velocity of skater A goes on top. So skater A, we said, is the 65 kilogram times it's going south. Ooh, hang on. The other one's going the opposite direction. So south, we better make that a negative 6.0 meters per second. And it runs into the other skater. What is that? 85. That's from right here. 85 kilogram. That's going to be our B skater. All right. 85 kilograms. Traveling in the opposite direction. And opposite direction of south is north. And usually we just do, I'll just put the positive there to remind us it is going in the opposite direction at 4.5 meters per second. Divided by the total mass. So 65 kilograms plus 85 kilograms. And now it's just solving. Okay, so you do have to be careful. You want to make sure you do order of operations correct. If you are in doubt about your calculator skills, then, hopefully you've got your calculator practiced. You know how to use your calculator. Bottom line is, this is it. It's just calculation now. So I'm going to see if I can put it all in one for me. So 65 times negative 6.0. Ooh, this is not going to work. I got to be careful here. In fact, just to make sure that I do the whole top. Let's see here. I think I hit the wrong button. Let's do insert. There we go. I'm going to put the whole top in separate parenthesis right there. So again, I'm kind of showing you like, okay, calculator tip here, right? Make sure that you divide the entire top by the entire bottom. I have seen it time and time again where a student will put it into the calculator wrong, so that basically that 85 times 4.5 gets divided right now, and then it multiplies the 65 times negative 6, and it's just a hot mess. So make sure you are comfortable with your calculator. Plus 85. Okay, now I was talking while I did that, but I'm 99% sure I put that in correctly. That does seem like a reasonable speed. If they're heading in opposite directions, they crash into each other. They're not going to be heading very quickly in the direction when they start to travel. But look we got a negative number. So negative 0.05. I'm going to go on a limb here and say it's meters per second, but let's double check that, right? Once you do this, everything gets like added together. So the kilograms down here are going to add together. They're going to combine. They're like terms. And then these kilograms over here and these kilograms, basically all the kilograms are going to cancel out with each other. And that will leave you with just meters per second. All right. So we did get a negative number, which means that the final velocity is 0.05 meters per second to the south. Okay, that's what our negative number means. All right, so hopefully that helped. Again, just to kind of recap, the idea is that you start with two objects and you end with one object because they combine together. Okay, they move together. That's your key, that's your clue that this is an inelastic collision. All right, so I hope that helps. Good luck.